sets we produce and analyse. So, to me, the Quaternary is just another kind of history. And the only data we have are historical. That's all we've got. It's all we will ever have. The data are historical. So the Quaternary, documentary, instrumental records are all historical records. So you might think that they are equivalent, but of course they're not. They're not strictly equivalent because of differences of validity, resolution, and accuracy. Documents are produced by people and can be biased by the writer. Lithostratigraphic records are incomplete, and stratal thickness and time are non-linear. The completeness and accuracy are not synonymous. It's not as if any of these sources of information and data are without problems, but they are all of a kind, they are all historical. And of course the future can only be known by extrapolation or by modelling, or by living long enough. But both approaches require data from the past. So the Quaternary fits into that category. Also, I would argue that we need to think about which view of time seems to be most appropriate. So, with that rather abstract introduction, I want to turn to the sort of phenomena that have interested me on and off over years. I will use some Australian examples, but I will also refer to Indian examples. So in natural resource, and of course the hockey stick graph here is perhaps the most famous paleoclimatic example. It had huge impact politically, some of it not very good, some of it very negative for the people who produced it. But it is an astonishingly powerful graph showing the rise of temperature in the last, since about 1900, set in the context of 1,000 years. So we need these historical records for the various phenomena that I've listed on the left, and you could probably think of others. So let's take some examples. There's a photograph of a very deep gully, which occurs in this particular gully is in southeastern Australia. This is a form of land degradation. There is some evidence that gullies formed before Europeans arrived, but they're very rare. This appears to be a phenomenon of European land use. Is that true? Identifying causes and solutions requires a temporal perspective. When did these gullies start to form? Why did they form? Is there something we can do about them? And also documenting trends in degradation requires a longer than usual perspective. So here's an example of a section in a riverbank. Underneath is the SM, the so-called swampy meadow, which was the surface of the ground when Europeans arrived with cattle and sheep and pigs and so on, goats. And on top of, and that contains no European artifacts, and it's been dated by OSL. It contains pollen of native species. On top of that is what is called PSA, or post-settlement alluvium. It includes European artifacts and has been dated by OSL as well. I'll get to that in a minute. The PSA is a result of deposition downstream of incisions into the swampy meadow material and the underlying Pleistocene sediments. So the PSA would appear to be a response to incision, and the incision is a response to European land use. The age of deposition, of PSA deposition, is in a sense the age of incision, upstream. Here is a section from Paul Rastomji et al. From CSIRO's work near Canberra, where they have many OSL dates done by Tim Peach, and very quickly it explains that PSA deposition began about 1900 Common Era. The swampy meadow is of late Holocene age, and the pre-swampy meadow is Pleistocene alluvium. So here we have clear evidence of some European impact. And so on the right-hand side, you see a graphical representation of many of these processes. At the bottom is another photograph of the swampy meadow on the left, is a unincised valley floor. That's what most of these valley floors looked like when Europeans arrived. Indigenous people used these areas, they burned them, but they didn't cause incision. On the right is the same stratigraphy that I mentioned before, the swampy meadow and the PSA. At the top is a diagrammatic representation of that, where it goes from swampy meadow through to an incised gully. But interestingly, on the left-hand side is the sediment delivery ratio. In other words, the proportion of sediment mobilized in the catchment that leaves the catchment. And you can see it's declining. And that implies that the gullies and channel incisions have been stabilizing. And they will do that by themselves, by negative feedback processes. And so, yes, soil conservation has been applied in this catchment, but in fact, the system will, to some degree, stabilize, and sediment yield and sediment delivery will decrease through time. So from this, we can conclude that the gullies and channel incision post-date European settlement. We know from a range of experiments and observations of local farmers that these incisions are caused by grazing and ploughing valley floors, and the valley floor on the right is another example of an unincised valley. And so one possible approach to stabilizing these systems is to re-establish the landscape that was there before Europeans arrived. And this is actually happening, and there has been some success in this, particularly at a place called Monsoon Creek. So the history, excuse me, the history, some of which includes Quaternary approaches, lithostratigraphy, chronometry, pollen analysis, even simple archaeology, and documentary evidence and oral histories of older farmers, all come together to provide us with a reason for and an argument for, well, what caused it and what can we do about it. And plus, in this particular case, in this place called Jerrabomberra Creek, where I worked with a colleague from Wadia Institute, Mazari, who was in Australia for a couple of years on an Indian government scholarship, and Ramkrishan Mazari. And we did a sediment budget for this Jerrabomberra Creek where we concluded that, and this did not include Quaternary stuff, it was really based upon measurements of quantities of sediment moving, that 93% of the sediment was from gullies and channel incision. So again, this is another line of evidence, along with the Quaternary and documentary evidence, to suggest a way forward. Plus, not only restoring the swampy meadows, but also fencing out the streams. But what about India? Well, there is some literature on the role of gullies in sediment yields in India, and I think probably Vishwas and others would know more about this than I. The Chambal gullies, however, are rather interesting in that they appear to be at least 400 years old. They were described by European travellers at that time. And there is a possibility that they're tectonically induced. In other words, the forebulge of the shield of the peninsula rising slowly, plus rainfall and probably plus land use, has induced major gully. But interestingly, if the Australian experience is anything to go on, and I'm now only talking about peninsular India, but gully erosion may well be a major contributor to, for example, sedimentation in reservoirs, which of course reduces the capacity of the reservoir, reduces the usefulness of the reservoir, etc. So we really need to be, we need a lot more to be done on that sort of work. Cyclones and floods. This is a recent image of Australia with a cyclone that was off the coast, just off where we live. They cause large floods, not the only cause of large floods. The question arises, do cyclones and large floods cluster in time? And if they do, standard risk assessments are not valid. Here's a piece of work that Ashok is involved in, yet to be published, a series of sites in Northern Australia, Northern Territory, where we've compiled data on paleocyclones and paleofloods. Here's one of the sites, Paleoflood analysis from Nitmalung Gorge. This is in a flood, nearly flooded season, and I've put a little arrow, which is difficult to see, where the slackwater deposit is located, and a lithostratigraphic and chronology section on the right-hand side. Similarly, for paleocyclone analysis at Casuarina Beach in Darwin, Stephen Garnett standing by a stack of storm surge deposits, and again, the dating, etc., on the right-hand side. No time to go into the detail. Sufficient to say that we have a reasonable story here. If we put all of these data together and a fairly simple statistical analysis, because there's not enough data to be very sophisticated, it seems that there are clusters at those dates, about 1920, 1416, 3026, 938, Common Era. So it's about 100 years ago was the last cluster. And pretty much all the gauge data, and of course all the satellite imagery for cyclones, is in the last 50, 60, 70 years. And 3 of those clusters occurred during La Nina-like conditions, which is important for the future. So, implications of the top-end analysis: clusters imply non-stationary series. In other words, the series does not have an approximately constant mean and variance of magnitude or frequency. Standard risk assessment, therefore, is not possible, but it's an input to risk assessment. And it's very interesting that almost all paleoflood records show evidence of non-stationarity. Here's an example from Southern Africa, from the Orange River, not the Ornage River. Now, the 2013 Alexander flood disaster, I had some fascinating discussions with engineers in Srinagar about this, who tried to argue that that event was unique. Well, of course, if you look at the disaster side of it, the human side of it, the 2 photographs from a paper by Naresh Rana and et al., you can see the change in over about 100 years in the number of people, number of buildings, etc. So you get the same event in 100 years ago, you get much less damage than you do now. We did a study some years ago based upon paleoflood deposits and others, Lenswara slackwater deposit on the right. And on the left, the most important thing is the graph showing the cumulative number of floods, and the bottom panel, that's not a stationary series again. So again, we've got a problem with the standard hydrologic method when we look at the paleoflood record. More importantly, perhaps, the 2013 event was certainly not unique. Now, Pradeep and his gang have done some wonderful work in the Siang River in the upper Brahmaputra, and some of their sections are on the left-hand side. Over the last 5,000 years, peak paleofloods have been around about 1 million cubic meters per second. This is 2 orders of magnitude larger than peak gauged monsoon floods. Most recent was about 1,000 years ago. Now, these are huge events by world standards. And how do we prepare for such events? They will happen again. In Thailand, work that Ashok was involved in again, we did a very detailed study of the Ping River. The left-hand panel simply shows that we did a lot of lithostratigraphic work and chronometric work. Most of the OSL was done in Ashok's lab. On the right is a block diagram showing that from time to time, this river strips its floodplain. The floodplain is stripped off. The channel widens up to 10 times and deepens. And the modern channel is shown in the middle, and the expanded channel is shown by the solid line. Now, these occur, we've dated them approximately to the dates that are given there. The 1831 date is the best known. There's at least 3 in that time period, about 1,000 years. There may be one much earlier as well, much more poorly known. When this happens again, I say when, not if. This is going to be devastating. Here's how the Thai people deal with floods at the moment. One way, they boat around. But with these floodplain stripping events, most of the infrastructure on the floodplain, which is immense, would be destroyed with a lot of loss of life. So the conclusions from this are long records based upon all the information we can accumulate allow us to identify causes, identify trends, and find solutions. For paleofloods and paleocyclones, evidence of non-uniqueness, clusters, non-stationarity again, which raises all sorts of statistical issues for analysis. Megafloods raise the question of preparation. There's very large floods in the Siang River, Upper Brahmaputra, and in Thailand, and there are many other examples. Can we really prepare for them? And I have to say, none of these is either linear or cyclic in the sense of Gould. And I'm going to end on a rather tricky note. Economists like to discount expenditure for disasters. So the argument goes like this. You spend money now to reduce the costs of future large disasters, which produces benefits in the distant future. Or maybe it's in the distant future. We don't know. It could be tomorrow. But statistically, it could be in the distant future. Therefore, the policy trade-off depends on whether these future benefits are discounted at a substantial rate, such as the 5 to 6% that is usually applied, or at the near zero social rate. The UK's Stern report on climate change uses the near zero social rate. Therefore, the standard economic approach is to the costs of infrequent large hydroclimatic events, such as the event 1,000 years ago in the Siang River, just disappear at high discount rates. There's no point in expending money to try to mitigate such an event because of the discount rate. So funds are allocated to mitigating smaller, more frequent events. That may be thoroughly rational. But can we even mitigate mega floods of the kind that I've described from the Siang and from Thailand? And it seems to me that quaternarists need to engage with these questions if they are to get involved in the sort of work that I'm talking about. So, Pradeep, I think I will end it there. And if there's any time, try to deal with questions.
Thank you so much, Professor Vasan. And yes, we have time to take few questions and 10 minutes for discussions. I'll request speakers or attendees.
Pradeep, there is a question in the chat box. If you can, Robert, if you can take it.
I'm trying to get out of this. How do I get out of this darn thing?
Okay.
Just, minimize, go to the main screen and stop presenting. Yeah.
Okay.
Stop presenting. Yeah. The blue button.
Right. Okay.
Thank you.
I request everyone to please switch off or mute your mic, except the speaker.
There's a question by Bhattacharya.
Now,
yes.
We have time for a few questions.
I have to say to Dr. Bhattacharya, please send me an email, wasson.robertj@gmail.com.
Right. Thank you. It was a comment, not a question. Sorry for the confusion.
No, that's okay. That sounds really interesting.
Yes, we have been trying to measure, use man-made reservoirs in peninsular India to understand the impact of arid droughts as well as floods.
Yes.
And sort of lakes are aggregators. So this is something that is currently under revision, but I'm happy to talk to you about it.
Yeah, great. Excellent.
Rajesh?
Professor Vasan, I just want to know your opinion on one very important issue here, as your keynote address, which was exactly focusing on that. People start saying, I'm just trying to say from the other side of the table, that we know we have enough data in Quaternary sometime, and we know that the climate is variable. But for the Quaternary scientist, the question is, what can you guys do about the mitigations? So what is your outtake about the climate change mitigations for Quaternary scientists?
Well, look, Rajesh, good to see you again. I think mitigation is a specialist business, and I don't think quaternarists by themselves, unless they are particularly multi-skilled, can do very much about it. I would suggest teaming up with people who are expert in this. Now, I've recently, because of where I was at the National University of Singapore, I was working with a lot of policy people and economists, and we published a paper a little while ago looking at floods in Assam, not from a quaternary perspective, looking at the gauge data and the embankments. And we really couldn't see any evidence for a positive effect of the embankments. In fact, the embankments are causing problems. But there is a quaternary aspect to this which Pradeep and I have discussed, and he made a start on it, but we need to discuss it again. One of the things that embankments may well do is to starve floodplains of sediment. And in the case of the Brahmaputra, the bed of the river is rising because of a flux of sediment, mainly from the syntaxis, which, the erosion rates in there are phenomenal. And the bed of the river will continue to rise, and the floodplain may not. In other words, the bed of the river may well rise above the floodplain. And the quaternary side of this is to get information about the rate of sedimentation on the floodplain, which Pradeep has made a start on. And it's very hard to get it from the channel itself other than by monitoring. But that's an input to mitigation. It's not mitigation itself. But what it does is to say to the engineers, look, your current approach may not be the best approach because you may actually be causing more problems than you're solving.
Yes.
So I think it's a matter of working with engineers, economists, hydrologists, and people who think about natural solutions to flood mitigation. I'm just talking about floods because that's what I mainly work on now. Now, for example, embankments do cause a lot of problems. And maybe we need better zoning, better planning of buildings, better and enforcing the building code, all sorts of things other than what quaternarists might think about. But if you're going to get into this business, form a team, work with other people.
Thank you.
And I think the same, I'm sorry, Rajesh, I think the same is true for climate change mitigation, just as it is for flood mitigation, or indeed earthquake mitigation. It's essentially the same story.
Yeah. Okay.
One more question. There are a few questions in the chat box. Pradeep, you are mute.
Ah, yes, right. What is the best proxy for reconstructing paleocyclonic events? Yeah, good question. And I'm going to leave cloudburst to other people. This is from Thomas Harrison. Wow, that's an interesting name. I won't try that one. Paleocyclonic events on the coast produce storm surges. But you've got to be careful, and they produce depositional records. But you've got to be careful to disentangle them from paleo-tsunami events. And the site we've looked at in Northern Australia, it's protected from tsunami. But in other places, such as the coast of India, that may not be the case. And a question from Mordecai. Greetings, Mordecai. Yeah, mathematicians or physicists invent new types of analyses to do our analysis. Interesting question. The hydrologists have come up with all sorts of weird and wonderful ideas to try to deal with this, including slicing the time series into very short pieces until they are stationary. And then you have very, very little data to work with. I don't think that's the solution. So I would much rather somebody with more mathematical ability than me to work on this. And also, Mordecai, what do you think our near future? Not sure what you mean, Mordecai.
I mean, when we try to predict for the future, right? I mean, how much future we have to, like 50 years or 100 years?
Oh, how far into the future? Ah, yes, thank you. Oh gosh. I mean, there are many ways of approaching this. One of probabilistic, which is essentially the hydrologic method. I would rather take the view that these very large events, such as the one that Pradeep and his team have identified, and we've identified in Thailand and many other people have done, take the view that that is something that can happen again. And we don't know when, but we should investigate the possibility of mitigation. And for example, in the Siang, I mean, some of the work that Pradeep has published is just terrifying. What those large events would do once the water got down beyond Pasigat and onto the plain. It's absolutely terrifying what would happen. I don't think anybody knows about that, Pradeep, but please tell me I'm wrong. Do the engineers in Dibrugarh know that there is a flood that big that could wipe out Dibrugarh?
Yeah, I think your message is very well taken that quaternary geologists and engineers should more often fight. And we should
more often fight
together. And we
Not
should
together.
spend more money on planning. Yes,
Yeah,
everything has a price tag.
Yeah.
Yeah. So I think if there are not, any more questions, we need to move on with the session. And on behalf of AUQR and the President, INCOA, and all the attendees and founder members, I sincerely thank Professor Robert Wasson for his really insightful talk and sharing all his experience and bringing in his wisdom to see how a quaternary geologist can really be helpful in planning and mitigation and disaster risk reduction. Thank you so much, sir.
Thank you, Pradeep.
So, friends, now it's time to move on with the presentations. Session 1. Session 1 will be moderated by myself and my colleague, Dr. Rajesh Agnihotri from Birbal Sahni Institute of Paleosciences. And I'm told that the first talk of this session is B.S. Kotlia is not presenting the talk. I would request, and it's almost about the time that we can start with the second presentation. Is Mohammad Tariq has joined? Mohammad Tariq? Okay, so Mohammad Tariq will be presenting on boron isotope-based pH record of last 3 decades from Arabian Sea coral records. Mohammad, please.
Yes.
Mohammed, please share your screen because we can't see us, otherwise we lose time. Yeah.
It's visible?
Yeah.
Okay. Hi, good morning, everybody. So I'm Mohammad Tariq. Currently, I'm a PhD student at NCPO Goa, working under the guidance of Dr. Waliur Rahman. So today I'm going to talk about one of my PhD work, which recently got published in JGR Biogeosciences. So in this study, we have generated the pH record from the Arabian Sea. So we have already seen this graph in this in our previous talk. So this is the instrumental record. Here we can see the atmospheric CO2 as well as dissolved CO2 concentration, this second line, and this bottom one represent the instrumental record of ocean pH. So what we can see, due to continuous increase in atmospheric CO2, there is increase in CO2 concentration of the seawater, as well as there is a decrease in the seawater pH. So this decrease in pH is called ocean acidification. So the chemistry of this is quite simple. What will happen when the carbon dioxide concentration in the atmosphere will increase? More CO2 will be dissolved in water, and it will react with water to form a carbonic acid. So it's a weak acid, and it will dissociate to form bicarbonate ion and hydrogen ion. So we can notice here that there is an increase in the hydrogen ion concentration of the ocean, which is also, we can say that there is an increase in the acidity of the ocean or decrease in the pH. So which is acidification. So if you see a bigger picture, so this is the atmospheric CO2 concentration reconstructed from the Antarctic ice core, and we can see in the last 800,000 years, the CO2 concentration was never higher than 300 ppm. But after this industrial revolution, in just 200 years, the CO2 concentration has reached to a value of around 415 ppm. And the model projection shows that this will reach to a value somewhere around 800 ppm. And why should we care about this? Because this ocean pH will reach to a value of around 7.7. And this, due to this lots of marine organism, it will become difficult for marine organism to form their shell, and it will also accelerate the dissolution of their shells. So here these instrumental records are available only for a very small time. So if we want to go back in time, to reconstruct the past pH record, we need two things. This first one is an archive, that is a material from which we can extract the past information. So for that, I'm using this boron isotopic composition, and for using corals, and for using a geochemical method, which is using boron isotopic composition to reconstruct the pH. So boron has two naturally occurring stable isotopes, 11 and 10 boron, and its isotopic ratio is represented in the form of delta notation, which is basically isotopic composition of the sample divided by standard -1 into 1000. And in ocean, this boron exists in the form of two compounds, that's boric acid and boration. So these two are related to each other by a reaction which involves hydrogen ion concentration, that means pH. So the abundance of these two compounds depends on pH. We can see this is the relative proportion, and these two compounds basically vary with the pH. And one more thing which we can notice here, this isotopic composition of these two compounds also varies with pH. So what happens when the marine organisms like forams and coral, they form their shell, they preferentially incorporate only this BH4- ion. So from the from the measurement of boron isotopic composition of these shells, we can reconstruct the pH of the ocean, and which can be estimated using this simple equation. And if you see the available record of boron isotope using corals, so most of these records are available only from the Pacific. Few records are available from the Atlantic Ocean, and from Indian Ocean, there is no record available from this whole ocean. So we decided to reconstruct pH from the Arabian Sea, and we have selected this Lakshadweep, and we have this Lakshadweep region. One of the reasons for selecting this site is that if we see this bottom panel represent the SST during winter and summer monsoon, and we can see there is large reversal or change in the wind pattern, as well as reversal in the surface circulation, and there are also changes in the upwelling and biological productivity during these seasons. So this is a highly dynamic region. So if you want to understand how different processes influence the pH, so this is an ideal site. So this is our boron isotope record as well as pH. So left hand side y-axis represent the boron isotopic composition, and right hand side y-axis represent. So and these bottoms are other proxies for which is carbon isotope, and these are proxies for temperature, and this is El Nino. So few things we can notice here is that there is a large variation in the pH record, 0.3 to 0.4 units, and other than that, there is no significant declining trend which we are expecting from the increase in the atmospheric CO2 concentration. And these blue bands represent the La Nina condition, and red bands represent El Nino condition. So during La Nina, we are seeing a lower pH, and while El Nino, we are seeing a higher pH. So, and one more thing, if you see the 13C record, we are also not seeing any significant declining trend. So to explain that, if you see, this is the carbon isotopic composition from the Antarctic. Carbon isotopic composition of the CO2 reconstructed from the Antarctic ice core, and we can see there's significant declining trend, which is due to burning of fossil fuel, because these fossil fuels are enriched in 12 carbon. That's why we are seeing a declining trend, and the same trend is observed in the coral record from across the globe. Okay, so this is called Seuss effect. If in our case this declining this thing would be dominantly controlled by the global CO2 signature, so we are expecting a declining trend in 13C as well as ocean pH, which we are not getting. That means that this at our study site, this pH variability can be dominantly controlled by the regional process or basin scale process compared to this global CO2 forcing. So to understand why this is happening, so we first try to understand whether there is an influence of El Nino at our site. So this is El Nino composite SST anomaly, which shows a strong positive correlation. So which shows that our study area is influenced by El Nino. And then this is the vertical profile of pH during El Nino and La Nina period. And we can see this is our study site. And we can see there is a large pH gradient in the top 50 to 100 meter. So therefore, if there is a slight change in the upwelling or mixed layer depth, that will have a large influence on the pH variability. And that's why we are getting a large variability. Other than that, if you see the nutrient content, there is also large variation during the El Nino and La Nina period. So this we can explain using this schematics. So during El Nino, there is a stratification due to which there is a decrease in the mixed layer depth as well as upwelling, and this, due to which there will be a decrease in the upwelling of CO2 rich or low pH water. So similarly, which will be reversed in case of La Nina. And from our study, we have shown that this physical parameter, basically this upwelling and mixed layer depth, are dominant factor which are responsible for large pH variability at our study area. So some of the major conclusions from this study are: this is the first pH record from 1990 to 2013 from the Indian Ocean, and we are not seeing any long-term declining trend in the pH, which is ocean acidification, because of large surface pH variability in the Arabian Sea. Other than that, El Nino modulated physical processes are dominant factor which are responsible for this variability. And other than that, this model projection shows that there will be increase in the El Nino intensity, and therefore we are expecting an increase in the pH extreme, which is critical for the these marine organisms. Thank you.
Thank you, Mohammed. It was a nice presentation. And we have time for two quick questions. One is there in the chat box from Anil Kumar. What will happen to boron if water is acidic in nature?
So as I have shown that the boron in seawater, it exists in the form of two species, boric acid and borate ion. So what will happen in we can see from the presentation. So out of these two species, at lower pH, this is the low pH, and this is 100% BH4 minus. So this abundance of these two species will shift. So at lower pH, this BH3 minus boric acid will be dominant. If we keep on increasing the pH, the other species will keep on dominating. So only the abundance of these two species will change.
What is the correlation between ENSO and Lakshadweep pH? Does Indian Ocean dipole has effect on Lakshadweep pH?
Yeah, this is a good question. Actually, due to time constraint, I didn't discuss that. So, since in our study, what we did, this El Nino has a periodicity which varies between that is 2 to 8 years. Similarly, this IOD also has a similar periodicity. So, what we did, we tried to we have estimated the periodicity in our record. This boron isotope record, as well as determine the periodicity of ENSO and IOD. So our record shows a periodicity of around 7.8 year, and which is very much similar to the El Nino, and this is not showing a similar periodicity in that thing IOD, and also the wavelet we did to determine what were the time period when these periodicities were dominant. So our boron periodicity was matching very much with the El Nino. So we have suggested that this is due to the dominant influence of El Nino rather than IOD.
All right, Mohammed, this is the time you had, and I thank you for managing your talk well in time.
So
I request you to please unshare your screen.
So Pradeep, is there any time just to, just
Okay.
tell something? Okay.
Yes, it is sir.
Yes, Mr. Tariq. So first of all, I congratulate you for your nice work, and you are working on the new proxy. But as the question has already been asked, this is the area that which is strongly influenced, by the Bay of Bengal water. It comes, you see, during the later phase of the summer monsoon. So you are correlating with the El Nino and ENSO-like events. So you need to be very careful, because once you have the more and more water, it comes from the Bay of Bengal, the fresh water, and your site is located in such a region that the surface water will be more stratified.
Yes, sir.
This is the one thing. And the second point is that are you really very sure that this is the upwelling area, because you are relating with the upwelling and the non-upwelling, the non-upwelling season. So these are the 2 points you need to have in your mind, that while you are interpreting your record.
Okay.
Okay, Mohammed, you need to get in touch with AD Singh Sahab on this.
Okay.
There is no need to respond right away. So I thank you for your presentation.
Okay, thank you, sir.
And moving on, the next presentation is Phanindra Reddy is there?
Yeah. Yes, sir.
Okay. Phanindra, please share your presentation. Phanindra will be presenting the mean monsoon climate shift at the edge of Roman warm period. Excellent. Please share your presentation.
Is it visible my screen?
Yes, please go ahead.
Yeah. Hello everyone. I am Phanindra Reddy, a final year PhD student at Indian Institute of Tropical Meteorology, Pune. I am doing my PhD under the guidance of Dr. Naveen Gandhi. To better understand the past monsoon variability, we have collected 2 stalagmites from the Kadapa Cave region. Kadapa Cave. The location is shown in the white star on the map, and monthly climatological rainfall values around the cave region suggest that more than 80% of the annual rainfall at this location is contributed by summer monsoon rainfall, and the moisture source during rainy season is drawn from the Arabian Sea. So this is one of the ideal location for studying the monsoon rainfall variability. So in this time series plot, this is an oxygen isotopic variation of the 2 stalagmites that were collected from Kadapa Cave. As we see that at the edge of the Roman warm period, around 1800 to 1600 years, we see a shift in the mean monsoon climate. And this proxy, as I shown, that the more negative values are the wetter monsoon, and less negative is a drier monsoon. So we would like to examine that, is it related to cave processes or real climate? Is it a real climate signal? We have validated our monsoon record with the available monsoon proxy records around the subcontinent and observed that the mean monsoon climate has shifted at the edge of the Roman warm period. As we see that the first panel is the Kadapa stalagmite composite of the two stalagmites, and the second panel is Western Bay of Bengal carbon isotopic data from the Godavari basin, and Northern Arabian Sea water thickness data, and Baratang island cave record. So as we see around this period, there is a declining trend in the monsoon till the edge of the Roman warm period, and a sudden shift in the monsoon climate is noticed from all the proxy records, which was also noticed from the Gupteswar sample as well as Munagamanu samples from the southern India. So we tried. Further, it is also noted that the Indian monsoon record shown such shifts in the past, sudden abrupt shifts in the mean climate changes from the Mumi cave data. And Cheng Hai, in his paper, discussed that abrupt changes in the climate system can occur within a decade also. So these are the potential monsoon forcings that can shift the monsoon variability or mean monsoon climate. Orbital parameters, solar activity, greenhouse gases, and volcanic eruptions, North Atlantic temperatures, tropical Indian Ocean temperatures. Tropical Indian Ocean temperatures and tropical Pacific temperatures, and the cross-equatorial flow, the strength of the cross-equatorial flow. In this figure, we have shown that the Indian monsoon during last 5 millennia with global forcings. The top panel is monsoon variability with solar insolation at 30° north. Second panel is the temperature anomalies from the corals, reconstructed from corals from the western coast of Sumatra Island, which are indicative of IOD phases. And the third panel is volcanism, and these are greenhouse gases concentration and North Atlantic temperatures and bond events, El Nino southern oscillation activity, like El Nino events and La Nina events. As we notice that the monsoon monsoon was continually declining in response with the solar insolation. But at the edge of the Roman warm period, we have noticed a shift in the mean monsoon climate. There are no significant volcanism activities around this period, the volcanic forcing, and there is no solar activity changes also. And we noticed that the positive IOD mean-like state at this period, and further there is an increase of El Nino and La Nina activities at the same period. And there is an exponential increase of greenhouse gases from 5,000 years onwards. So we also seen that this shift is occurred around when the solar minima is presently we are in the solar minima values. So during last 35,000 years, we see that last glacial maxima where there is a solar minima, and presently we are also in solar minima, and there is another solar maxima at this period. And we noticed that there are abrupt shifts in the monsoon, both the solar minima, solar minimas. So this is the temperature from the eastern equatorial Indian Ocean off coast of Java. islands, and wherever whenever the temperature is higher, which is coinciding with the dry monsoon events, and when there is a less temperature, cooler temperatures, and we notice a increase in the monsoon intensity, and which is nothing but these are the positive IOD mean like state in the last glacial maximum also noticed. So we try to explain the atmospheric phenomena, circulation, using atmospheric circulation phenomena. During the positive IOD phase, there is an anomalous Walker cell and Hartley cell, and there is a strong equatorial, cross-equatorial flow, which favors the monsoon during a positive IOD phase. So we are confident to say that mean monsoon climate shifted at the edge of the Roman warm period, which is evident from several monsoon proxy records around the subcontinent, and such shifts are observed during each solar minima and maxima. During last glacial maximum, positive IOD like mean state prevailed and coinciding with the enhanced monsoon. Similarly, around the edge of the Roman warm period, positive IOD mean state is prevailed and favored the mean monsoon climate to shift. A linear response of the monsoon is observed during each solar minima to the internal forcings, like oceanic forcings. So, though the solar forcing remains the primary driver of the long-term monsoon variations, internal forcings such as ocean forcing like IOD intensification may dominate and dictate the monsoon variability. Thank you.
Okay, Farid, thank you so much. We have 1 minute for a quick question. Is there any question? Okay, Dr. Karumuri, please.
Yeah, Panindra, it's a nice talk.
Yeah.
I just wanted to know what sample, what proxy you took for ENSO records.
What proxy for?
For ENSO, you must have mentioned it, but I missed it.
Yeah, this is from Moy et al. Data, red color intensity data. Moy 2002.
Okay, good. You might also want to see the not only the El Niños in Indian Ocean dipole, but the slow changes in them. There are decadal variants of ENSOs and IODs. Whatever proxy data you have, they may be having signatures of Pacific decadal oscillation in Indian Ocean dipole. And ENSO signal itself is there in. Anyway, those are other part is complicated. You can just see that and also think of doing some model output analysis.
Yeah, sure, sir. Thank you, sir.
Thank you, Dr. Ashok. I mean, Fanindra, you can get in touch with Dr. Ashok Karumuri through email. Sure. And I thank you for your presentation. Please unshare your screen.
Thank you, sir.
Now we move on to the fourth presentation. Dipanvita is there?
Yes, I'm here.
Okay, great. Dipanvita will be presenting variability of Indian summer monsoon strength in northeastern India in past 3 millennium. Dipanvita, please share your screen.
Yes, sir.
Great.
Okay, so is my PPT visible?
Yes, please go ahead.
Okay. Good morning, I'm Dipanvita Sengupta, an SRF working in the Wadi Institute of Himalayan Geology. I will be talking about the variability of the Indian summer monsoon in northern India the past 3 millennia, and also how the Indian summer monsoon varies in space and time in the past and also in the recent times. So this will be the outline of the presentation. I'll be introducing the study area and objectives and how ISM has varied in space and time, and how I have age modeled the sample and the study results. So the Indian summer monsoon is a highly variable ocean climate coupled phenomena, and it affects pretty much the habitation, the livelihood of the people, and the pattern of civilization in the Indian subcontinent. In this figure, I've shown how the Indian summer monsoon works. So the ITCZ shifts northwards in the boreal summer, creating a low pressure, attracts the moisture-laden winds from the oceans, and that is how the southwestern monsoon works in the summertime. So the motive of this work is to add to the inventory of the Holocene records of ISM, because it is quite fragmented. So we're trying to add more ISM variability records into the Holocene. So in this study, I have chosen a stalagmite from the northeastern India, which captures the variability of the Indian summer monsoon, and also how the ISM is related to different climatic phenomena from across the world, related to all the teleconnections, and how the ISM has affected the socio-economic behavior of the subcontinent. So in this figure, you can see the past 200 years record of the Indian summer monsoon, that is very recent times. So you can see that the Indian summer monsoon varies quite much in space and time. So these records show 31-year average Z scores from different regions of India, and it is clearly visible that the intensity of the ISM is not same in all the places of India, and different forcing factors affect. Also, during the inter-Holocene, the ISM has quite much varied, and from different regions, it has not been the same. So my study area is the Mangrove cave in the northeastern India. It is situated in the East Khasi Hills in the Shillong, in the southern part of the Shillong Plateau, and it receives about 2,600 millimeter of rainfall per year, and the rainfall is extremely seasonal. About 70% of the rainfall is concentrated in the monsoon months. So it is a good place to study the variability of the ISM. So in this this figure shows the age model of my sample. So it spans from 1,000 calibrated USBP to 3.9 calibrated USBP, and it can be seen that in the initial and the final stages of the stalagmite growth, the growth rate was quite high compared to the middle part of the sample. Coming to the study results, so this is a 23 centimeter long stalagmite sample from the Mangrove cave, and in the blue curve shows the oxygen isotope variation of the sample as the samples have been collected from the central axis of the sample at 0.5 millimeter interval and measured in the ILMS. And the green curve shows the delta 13C of the carbon isotope variation along the length of the sample. So it can also be seen that during the initial and the final part of the growth of the sample, the ISM shows stronger. The ISM was strong because it shows more negative oxygen isotope values compared to the middle parts, where the oxygen isotope shows less negative values, indicating less intense ISM during that period. So it is the growth rate of the sample and the strength of the ISM is also coherent, we can say from this. So this part from around 2.9 to 3.2 kilo years before present, this part coincides with the minimal warm period, and it was a warm period and the ISM was strong during that time, and it also coincides with the flourishing of the Vedic civilization in India. And during the around 1.1 to 1.4 kilo year before present, this period also shows a stronger ISM phase here. However, this phase coincided with the dark ages cold period, but this study shows that the climatic forcings is not uniform in all parts of the world, and some local phenomena also affect the ISM strength, such as the happening of the Indian Ocean dipole. And other studies have also shown that during this time there was upwelling Arabian Sea of the G bullies, which also indicates that there was stronger ISM during this time. So this is what to say that the Indian summer monsoon is a highly variable phenomena, and it has varied quite much in space and time in the past and the present, and the climatic forcings has affected the Indian summer monsoon in different ways, and it is not necessarily uniform. And we are still developing this study with improved age models. And that was, thank you for your patience. That was all for today's talk.
Thank you, Dipanvita. And we have 2 minutes for few questions. The first question I already see in the chat box. The question is, when does cave carbonate precipitation is maximum in Mangrove? Whether it is during winters or it is summer?
The carbonate precipitation is maximum during the summer time, during the summer monsoon, because the non-monsoon months are dry. The rainfall is quite seasonal in the northeastern region.
I have one question here, because a lot of people are working from northeast region on the cave deposits. Hello?
Yes, sir.
Very simple, but if you can address that. My question is the kind of, the magnitude of the delta attenuation change which you see, let's say from 4.2 to 3.9. Have you tried to see it in the real-time data, like collecting the rainfall, how much data attenuation in terms of millimeter of rainfall it corresponds to?
No, sir, I have not tried, but it's a good suggestion.
Okay.
All right, now we can have a question from Dr. Ashok Karmani.
Yeah, thank you, sir. Dipanvita, it's a nice talk. As far as I'm concerned, I'm a layman as far as paleo crop analysis is concerned. But one thing is northeast monsoon relationship with the rest of the rain monsoon rainfall of India is not so strong. Actually, if you talk more, they become as opposite, but not necessarily related. There is a disconnect. And in our analysis of the model outputs, a few models, for last millennium at least, there is not much change in the northeast monsoon rainfall. Summer monsoon, northeast India, other places. I suspect this is a problem with the models also. My question is, have you compared these your regions with the other proxy data from northeast? And also places around India.
Yes, I have compared, and even from the same cave, the samples do not match.
Okay.
Rainfall
signals from other places in India?
Yes, I have compared, but I haven't found any very good match with the.
Okay, Naveen, now we are short of time, so probably I request you to please correspond Dipanvita through email. Thank you. Dipanvita, you can share your screen.
Okay, sir.
The next presentation will be Sumit Sangwal. Sumit, are you there?
Yes, sir. Yes, sir.
Great, please share your presentation. Sumit will be presenting lake level fluctuations and hydrodynamics of larger lakes from Trans-Himalayan 33 kA.
Good morning to all. My name is Sumit Sangwal, SRF at Boron Institute of Himalayan Geology. I am going to present the lake policy, lake level fluctuation and hydrodynamics of larger lakes from Trans-Himalayan since 3 kA. The outline of my presentation will be the introduction to the problem, why we use the lake delta of the arid Himalaya, my objectives, studied area, methodology adopted, and inferences. As you know, the geomorphological evolution of landscape of any region mainly depends upon the climate tectonic interaction and the surface processes occurring there. If we talk about especially about the Himalayan region, Northwest Himalaya receives precipitation mainly from two sources, that is in summer from Indian summer monsoon, which carried moisture from westerly driven disturbances which carry moisture from Arabian Sea and Bay of Bengal. And second, in winter from the westerly prevailing disturbances, which carry out moisture from the Mediterranean Sea. And throughout the Himalaya, we can see two high precipitation lines. One is near to the HFT and second is near to the MCT. These high precipitation lines are owing to the sudden increase in altitude, which is known as the orographic barrier. Due to this orographic barrier, despite of the extension of ITS to 34 or 35 degree latitude, there is very few precipitation in this trans-Himalayan region, that is less than 0.5 meter per year. Due to this very few precipitation or less precipitation, it is known as the cold desert region of India. In this region, the main geomorphological features are the glacial moraines, fluvial terraces, larger lakes, and Paleolithic deposits. Out of which the fluvial terraces, glacial moraines, and Paleolithic deposits are being extensively studied by geologists to establish the past climatic shifts occurred during Quaternary time period. But larger lakes, in case of larger lakes, there is gap in literature regarding the hydrological changes and lake level fluctuation histories of the larger lakes during the Quaternary time frame. To study the hydrological changes will provide us about when we see the scenario of global warming, when higher Himalayas of Himalaya and Tibetan plateau are expected to warm dramatically, it is important to understand how these lakes may behave. Therefore, the reconstruction of the lake records for their fluctuation, their hydrological change can provide us about the base for the modeling of futures in this climatic changes phenomena. To study this set objective, we concentrated our study on the Pangong Soar, one of the largest lake in the Trans-Himalayan region. This Pangong Soar is a saline lake situated in Pangong strand of the Karakoram Hole and receives meltwater from the numerous streams from its catchment, and there is no outlet to the lake. Due to this, consequently, the lake has quite higher salinity, and the periphery of the lake have beautiful classical Gilbert type of delta, which are exposed by the incision of the peripheral streams. These lake deltas have thin, flat-laying bottom set that are being deposited in deeper water condition. Deltaic foreset, these are wedge-shaped deposition during the progression phase of the deltas, and relatively thin and flat-laying top set of delta that are being deposited in shallow marine condition and shows as the paleo shoreline condition.
4 more minutes to go.
Yes. To define, to achieve the objectives, we adopted the methodology, the sedimentological and geomorphological evaluation, the chronology established by optical stimulation techniques, chronology, stable isotope analysis of lake and periphery streams, and we used one biological proxy diet for population. To establish, we identified 4 sections of deltaic deposit in the periphery of lake, which extend up to 600 meters from the lake and attain a maximum height of 6 meters. Present from the present day lake level, and these deltaic sections have gastropod bearing layers. We we had taken the sample of 4 set of these lake delta for establishing the chronology, and the gastropod cell samples for chronological analysis. The chronology is established by using OSL dating technique on the quartz skin. In sample we have a dull signal region with the K feldspar grains for the dating purpose. While dating the K feldspars, we encountered the problem of fading signal, for which we carried out the fading correction in K feldspar. On the collected gastropod cells, we carried out this chronological analysis on mainly the radix cell. These are all the freshwater origin cells, and these chronology can tell us about the physical and chemical condition during the lifespan of these cells. And for a typical radix cell, the time span of their lifespan is approximately 1 year, so they can talk about they can tell us about the seasonal variability. For the reconstruction of the temperature and salinity of the lake, we collected the modern day water sample and carried out the stable isotope analysis, and the bivariant plot of the salinity and delta oxygen rating shows a very well correlation, that is R-square value 0.99 we used to model this linear equation to model the paleosalinity of the lake, and we used the equation given by Grossman and to establish the temperature using the gastropod cell. And here we can see for an example of a cell, we can clearly depict the seasons in which the cell has been get lifespan during the cell. We identified the fresh water loving diatom from the gastropod bearing sedimentary layers. These are some of the diatoms are like Stephanodiscus, Epithamia, Coconis, and these are of freshwater origin. So, based on the OSL chronology of the top set of the deltas which have gastropod bearing layer, we are able to identify 2 phases of freshening in the lake. One is from 2.8 to 2.2 kilo year before present, and the second is from 1.7 to 1.1 kilo year present before present. And this shows that the lake salinity and temperature was below to the present day salinity and temperature of the lake, and these phases are well correlated with the delta D value on the leaf wax provided by Howard, and also during these phases the concentration of saline diatom was decreased, provided by Gus et al. 1996. And this can be
you should sum up now.
In the by watching present day landscape, we can see that Pangong, so lake level has been fallen approximately 4 meters during the past 20 years. Thank you.
Thank you, Sumit. I fear that we do not have time for discussion, but I request the audience to please type your questions in the chat box, and all the presenters who have presented their talk, they can attend to the questions. Thank you so much, Sumit. I request you to please unshare your screen. Speaker Roy is there?
Yes.
Okay. Now I request Speaker Ipsita to please present to share your screen.
Yes.
The paper is Climate Variability During Holocene at Betuliani Glacial Valley, Western Himalaya. Sita, please.
Hello everyone. This is a part of my PhD work where I have tried to find out the climate variability during Holocene at the Neogene-Quaternary Valley, which is at the western Himalaya. So the Himalaya plays an important role in the hydrology, biodiversity, civilization, and the economy of the Indian subcontinent. Due to global warming, there is a recorded average temperature rise, especially during the second half of the 20th century. So this warming trend has introduced changes in the hydrology and the biodiversity of this Himalayan region. In the Himalayan region also, the subalpine and the alpine altitudes are more sensitive to the climate change and are important for understanding the paleoecological variation. So it becomes important to understand the long-term climate variability and what would be its impact on the vegetation and the glacial dynamics, so as to predict the future climate for a sustainable management of the ecosystem. Even though meteorological data is available from the Himalaya, but it's for a short duration, so as to get the long-term climate variability data at temporal and spatial scale, that has been studied through the proxy reports such as polar stable carbon isotope, ice cores, photon, spherogram, rings, etc. So I have chosen this study area, that is the Neogene-Quaternary Valley, which lies in the western Himalaya, and the precipitation over here is being influenced both by the Indian summer monsoon during the summer months and the western disturbance during the winter months. So these are a few photographs from the sampling site where A and B shows the vegetation distribution at this area. The vegetation here at the sampling site is mostly of juniperus, petuna, then rhododendron, iris, and so on. And C and D is the subalpine meadow from where we have collected the core, the subsurface sedimentation core, for studying the proxy. So this subalpine altitude from where we have collected, this is at around 3,500 meters sea level. So for this, before generating the past vegetation and climate data, I have generated the modern pollen vegetation relationship that has been studied from the valley. The moss samples were collected at an altitudinal gradient representing the different vegetation zones. And then after inferring this present pollen vegetation relationship, then I started studying the past vegetation climate. For this, the 125 centimeter core was collected, which was of 125 centimeter deep. So then the palynology and the stable carbon isotope data sets were generated for the sedimentation profile at PSIP, and the radiocarbon dates, that is AMS-C14 dates, were done at IUS in New Delhi, and few conventional radiocarbon dates were done from PSIP also. This is the composite diagram of the pollen assemblage and the delta 13 carbon values from the core. So the radiocarbon dates are both from AMS and conventional radiocarbon methods, where 5 dates are from AMS method and 2 are with the conventional method. So the date extrapolates to around 11.6 kADP, and the fluctuations in the palynological and the delta 13 carbon values, they have been zonated into these 7 zones according to the whatever fluctuations is being visible in their assemblage. So that also denotes the ecological shifts and the ecological variations. So these here in this diagram, I have tried to plot a few major taxa which shows ecological shifts, and along with it the delta 13 carbon data set from this study. And here I could get these 3 climatic phases where since my core extends to 11.6 kADP, so I could get an extension of the YD till around 10 kADP. That was being evidenced by this high steppe value that is the dry indicating taxa. Also, the delta 13 carbon value over here was around -26.5 per mil. So then after which it shifted towards a more moist climate, as also indicated by this moist taxa, and a drop in this steppe taxa. Then it was around 8.5 kADP. Rise in the arboreal taxa was seen that shows that the establishment of the arboreal taxa took place towards this sampling altitude from around 8.5 kADP. Then it was again at around 6.5 kADP, where an increase, a gradual increase was seen in the moisture-loving taxa, and the percentage of this moisture-loving taxa at around 6.5 kADP. Then this gray bar that shows a dry phase, that is the 4.2 kADP, also seen in the data set as evidenced by the delta 13 carbon data set around -26, around -26 per mil, at around 1.2 to 0.8 kADP. There was slight increase in the moisture-loving taxa that went up to around 45%, and also a drop can be seen in the delta 13 carbon data set towards more negative, that is -27.5 per mil. So that shows a moist phase, and also which brackets the medieval warm period, the globally documented medieval warm period. Then I compared my data set, my steppe taxa percentage, and the delta 13 carbon data set from my study, along with few other studies, the reported studies such as the GIS2 isotope data set, then the Mangrove cave data set, the delta of Mangrove cave biological column, and the G-Veloidis percentage from the Arabian Sea. And also there was a coherence was seen among these published data sets and the data that is being generated from this Tokyani Glacier Valley. So, coming on to the conclusion, since this is a high-resolution hydroclimate data set, since 11.6 kADP, so more such data sets are being required at a finer resolution from the different precipitation zones, so as to have a finer climatic, the paleoclimatic data set, and which can be used for a predictive modeling of the future. Then from my data set, I could record the dry climatic events such as the younger dries and the 0.2 kADP, and also the moist climate as 6.5 kADP and during this medieval warm period. And after this medieval warm period, an increase in delta 13 carbon values was being noticed since around 0.8 kADP that indicates towards a gradual shift towards the dry climate. And when I compare the present data set, the present pollen vegetation relationship with this past vegetation data set, so I could conclude that this present vegetation represented its study area since 400 years BC. Thank you.
There are questions in the chat box, and I request you to please address the questions from there itself. And it's the time to move on with the next presentation. Sayyid Azharuddin, are you there?
Yes, sir, I'm here.
Okay.
Can you hear me?
Please share your presentation.
Okay, just a second, let me share.
Azharuddin presenting a high-resolution record of nitrous oxide variation from the South Pole during the Holocene. Great.
Hello everyone. I'm Sayyid Azharuddin. I work at National University. I'm a postdoc here, and I would like to acknowledge my co-authors.
Share your screen.
You can see my screen now?
Not yet.
Maybe. Can you see now?
Yes.
Now it is done.
Hello everyone. I'd like to acknowledge my co-authors for this work. And in my talk, I'll be introducing my study, and then I'll talk about my study area, and then a little about methods, and then I'll show my results, and then I'll show some conclusions about my results. So first of all, a little introduction about ice core studies. If we see in an ice core or a pressurized ice sample, those are quite different from the normal ice we have in our freezers. We can see these small bubbles which in the ice, and these small bubbles are in the pressurized are the remnants of ancient air which were trapped during the snow accumulation, as you can see in the right figure. Slowly with the snow accumulation and fresh snowfall over the surface, this gets solidified and becomes glacier after several hundred years or 1,000 years. So basically, our job in this study was to study the nitrous oxide concentration, which is an important greenhouse gas, and it is actually very important because it has larger greenhouse gas potential than CO2, and it has another property of ozone destruction. So that's why this is an important gas. So the primary sources of atmospheric N2O are nitrification and denitrification processes, which occur in terrestrial soil, as well as in ocean, and the main thing is through the photolysis in the photosphere. So in this study, our aim was to study the high resolution N2O during the Holocene by using the South Pole ice core record and other existing records. So a little introduction about my study area. The South Pole ice core ST-14-4 was drilled during 15 and 16 coring sessions by American ice core group. And then the elevation at that site is around 2835 meters, and the snow accumulation rate is currently around 8 centimeters per year, and the annual temperature of the site is around -51 degrees. Coming to the method, you can see in this figure that normally there are two parts of our methodology. First is the extraction part, where we extract the air which is entrapped inside the glacier sample. So we use this freezer room which is maintained at around -22 degrees, so that the ice won't melt during the sampling. So we cut the ice here, and we use this special setup in our lab where we use sample cups, and then we submerge these cups in pre-chilled ethanol baths, and then after some time we put it in 60 degrees hot water bath so that it could be melted, and it goes to a specialized vacuum line by which it goes to the GC, and then it could be measured. The N2O is basically measured using micro-ECD detector in the Vegetation. So basically, for our study, the average standard deviation of replicate from the state depth, same depth is around 1.3 parts per billion. This, coming to the result, this is the record we generated for around 10,500 years, and there were some points around 11,000 years. So basically, the concentration of N2O varies between around 273 ppb to around 253 ppb, and we see that there is a maximum around 10 kilo air, and then there is an N2O decrease between 6 to 8 kilo air, and again we see an increasing trend from 6 kilo air onwards. To check the to gain more confidence on our measurement, we compared our record for 2,500 years with the previously measured record from other ice cores, that is NEEM and 6, which are recently published from our lab, and they were measured in the same facility. And this red line shows the ice record, and this blue and yellow line shows the record of NEEM and 6 ice cores. And as you can see that overall our record agrees well with the previously measured record, so we gain more confidence over our measurement. And then since our results do not cover full Holocene, so we took help of other ice core and geo records to make to complete our full Holocene record. And then we used EDML, cell-based, not scrape, neem and stick ice cores, and made a new N2O composite for the Holocene period. And the work is submitted recently for publication. And in this N2O composite, we basically see 4 major periods of N2O change during the Holocene. And first is, as you can see, there's a blue bar, which is from 11.5 kiloyear to around 10 kiloyear. We see the very high, like around 15 ppb of N2O increase. And then after 10 kiloyear onwards, till around 6.2 kiloyear, we see an N2O decrease. And then there is another increase between 6.2 to 2.2 kiloyear, and then another local minimum of N2O around 1.4 kiloyear before present. So, using the N2O record, we calculated the N2O flux by using the two-box model. And then the flux, N2O flux in teragram nitrogen per year, it varies between 10 to 11 teragram nitrogen per year. And as you can see that it matches very well with the N2O concentration record, where the highest increase is seen between 11.5 to 10 kiloyear, that is the period of pre-boreal. And then there is another decrease between 10 to 6 kiloyear onwards, and the same trend follows. So basically, we tried to study the mechanism of N2O variation. So we did some literature survey. So recently published record says that nitrous oxide production in terrestrial soil basically depends on temperature and precipitation, which alters the soil texture, moisture content, microbial ecology, as well as substrate availability in the soil. And then the precipitation shows a globally constant trend with increase in precipitation. With increased precipitation increases the N2O emission, whereas the decrease in precipitation decreases the N2O emission from the area. So roughly, if we see the regions of N2O emission, the highest N2O emitting terrestrial regions are the major monsoonal regions of the world. That is American monsoon, Asian monsoon, and African monsoon regions. So, coming to the marine records, if you see the marine records, the major upwelling regions, that is the Arabian Sea and the Eastern Tropical South Pacific, are the major contributors of atmospheric N2O. So basically, we compared the paleotropic records with our N2O record from the major monsoon regions. As you can see that between 11.5 to 10 kiloyear, there is highest increase, which shows that increase in Asian monsoon regions, whereas it doesn't match well with the other monsoon regions. And if we compare it with the marine record, the marine record shows a much better correlation with N2O emission during the Holocene, with highest increase during the pre-boreal time. And there is a big weakening of oxygen zone at Peru margin, Chile margin, and Arabian Sea. Just 2 minutes. So, and then there is an increase in ocean denitrification, which can be seen in increase in N2O. So we did some correlation analysis, which also shows the similar results and strengthens our observation. So finally, coming to conclusion, that between 11.5 to 10 kiloyear, there is an intensification of northern hemisphere monsoon, as well as South American and Australian monsoon, which may have contributed to the N2O emission. And coming to marine, there is an intensification of the minimum zone around Arabian Sea and Chile margin, which may have contributed to the N2O emission during that period. During 10 to 6.2 kiloyear, weakening of South American monsoon took place, as well as the minimum zones around Arabian Sea and Eastern Tropical South Pacific, both Peru and Chile margin have been observed. That may have contributed to the weakening of decrease in atmospheric N2O during this time period. Coming to 6.2 to 2.2 kiloyear, intensification of South American monsoon and Australian Indonesian monsoon took place, which is
I have to stop the presentation.
Thank you very much.
And we have some questions in the chat box that you are requested to attend.
Okay, thank you very much
Sorry for stopping you abruptly, but we need to maintain time.
Okay, thank you.
Now, is Dr. Ruby Ghosh there with us?
Yes, sir. I am here.
Ruby, please share your screen.
Okay.
And
So is it visible?
Not yet.
Not yet.
Let's welcome Dr. D.M. Banerjee sir. Banerjee sir, welcome please. And Ruby will be presenting evolution of Indian summer monsoon in the Bengal region during the past around 10 KA and coupled shift in lacustrine ecosystems. We will take the time.
Okay, sir. Is it visible now?
Yes, please go ahead.
Okay, sir. So on behalf of my co-authors, I am here to present a work on evolution of Indian summer monsoon in the Bengal region, and the history covers for last 10,000 years, and shift in the lacustrine ecosystem. So without wasting much time on why this ISM variation is important to us, because we all know that ISM is integral part of Indian agricultural based Indian socio-economy, and even a minor change in ISM can be devastating for us. So we have targeted a region where which is under sole influence of Bay of Bengal branch of Indian summer monsoon, and not much work has been done regarding this. No systematic study has been done for ISM variation from this area, that is the Bengal region or Bengal basin. We have targeted the northern part of Bengal basin, which is you can see from this map, rainfall map, that is it comes under a high rainfall region, and I can mention here that this region receives 30% more rainfall from other parts of India. So understanding the ISM variation from such a high rainfall region with the help of lacustrine archive is a difficult task. So we applied a lot of other proxies, to understand the variability observed in the ISM in the last 10,000 years. So to do so, we have collected, we have dug a trench in as you can see, this is a wetland within a deep forest situated at the northern part of the Bengal basin or the foothill regions of the eastern Himalaya, which receives maximum precipitation. And by this time, and this is, as you can see, this is dried lake, and from where we have dug a 2-meter profile and collected sediment samples, and we have 5 AMS dates to build our H-depth model using Boron, and this is the H-depth model. And so this sedimentary archive covers preserve the history of the last 10.2 kilo year span. And as I said earlier, we have employed a number of proxies to understand the changes in the lake level, as well as if we can also find out the driver, which is the most influential driver, whether it is temperature or precipitation. So to do so, we have applied non-polar paleomorph, phytolates, stable carbon isotope, magnetic and environmental magnetic parameters, and grain size parameters as well. And with the basis of this proxies like this NPP, including the algal, fungal, and geological remains, we have identified several phases of changes in this 10.2 K span. And phytolate data are also showing the similar trend, but not only we have used this phytolate spectra, we have used some phytolate indices which are globally used for direct climate interpretations. For example, the IC or RIC, revised climatic index, these are linked to the mean temperature change, and these index are this climate index actually portrays the ratio of the C3 or C4 gas variation in any any given time span. Another index is IPH, which distinguish between the C4 dry loving or C4 wet loving grasses. That means it shows you the balance or dominance of dry loving or wet loving grasses in an ecosystem. That means the wet or dry condition, and F is the water stress index. We also have used the stable isotopic variability here. So, and these are the variation of the environmental magnetic parameters and grain size parameters along the sediment profile. And just I want to mention here that this profile is a silt dominated one, and here the silt percentages are showing high correlations, strong positive correlation with the susceptibility, magnetic susceptibility, whereas clay percentage are showing negative, strong negative correlation with the magnetic susceptibility. That means with the high energy condition or intense rainfall condition, more silt will be deposited, had deposited in the profile. And but surprisingly, sand percentage do not have any correlation with any of the magnetic parameters. So these are the variability absorbed. So on the basis of this variability, we can see that there are successive changes in the this lacustrine profile, and from a deep lake condition to a marshy land, their lake has gone under several phases of changes. And to see whether our how far our observations are reliable, we have done also the principal component analysis on the biotic data like NPP and phytoliths. And you can see that this NPP data here, in both the cases, PC axis 1 are the most influential axis. For NPP data, and the PC axis 1 shows captures the signature of the lake evolution, where the you can see these samples, the sediment samples from the left side of the axis 1 are showing the signatures of high lake stand, whereas gradual decline is shown in the right side, which is these sediments are showing the low lake stand or gradual decline in the lake level. But phytolith data preserve the climatic signal. As I said earlier, phytolith data is the climatic signal, and from left to right side, high monsoon or wet condition to comparatively dry condition is seen. So combining all these data, we can say that there are several phases of changes in the last 10 kilo-year span in the Bengal Basin region, and to see whether these changes are coherent in the BOB ISM realm. So we have compared our proxy records like RIC, IPH, and silt percentages with North Bengal, BOB sea surface salinity record, and Delhi and Alkane record from the North BOB, which are monsoon proxy record and salinity records, and also terrestrial oxyanisotope records from Dongi Cave and Mamlu Cave, Northeast India and China. So, although I admit that this our data is comparatively of course resolution if we consider the other data, but overall a similar trend is observed in the ISM variation across the ISM BOB region prelim. And when we consider to understand the major forcing for ISM change, we consider the other proxy records from known forcing of the ISM, like the solar insolation titanium record for the ITCZ dynamics and northern.
You have 1 minute to summarize.
Okay, sir. Yes, I am summarizing, sir. Northern hemisphere temperature anomaly record, and we find that for the millennium scale ISM changes, ITCJ and solar insolation are the two major forces, and but centennial scale changes are driven by several forcing working collectively. For example, I can just tell that that 4.2 kilo year event, when not only there was a decline in solar insolation. ITCZ was moved southward, and at that time the ENSO variability was also.
You have to unmute yourself.
All right. So thank you, Pradeep, and everyone else for having me. So I am going to take off from where our keynote speaker left off, that this is an exercise in paleoclimate, but it started off what we thought would be a paleoclimate exercise, but it was motivated by understanding human environment systems. And as Robert said, that this requires a team of people with different skill sets. So you can see a host of people. I'd specifically like to mention Sudipto Sarkar at ICER Pune, Jill Leonard Pingo and Andy Michelson, who are paleontologists. Sudipto is a geophysicist, and then Anup, Praveen, Supriyo, and the rest of us, quite a few of us are geochemists. And then we have A. Bhattacharya from IIT Kharagpur, who is a petrologist, and M. Harvey, who is an arid environment specialist. So this is a work that's currently under revision. And I'd also like to specifically mention Rajagopalan Balaji at the University of Colorado Boulder, where I'm from, and Gaurav Arora at IIIT Delhi, where I hold an adjunct position. The first one is an engineer, and the second one is an economist. And in a minute, I hope to convince you that the motivation requires participation of not just earth scientists, but people outside those domains. So yes, these are man-made lakes or reservoirs or talabs, differently called in different parts of our country, and also known by several names across South Asia, especially arid regions of South Asia. So one of the motivations for this study came from the fact that statistical studies are telling us that there's going to be wide-scale social disruption, particularly human migration, in response to even a 2 degrees Celsius warming in temperature. Now, the top panel is the current population density. India and China and Western Europe sort of stands out. And the second panel is a response to 2 degrees Celsius changes. You see, more than 500 kilometers of vast human displacement and migration. And one of the questions we wanted to know is that we don't pack our bags and go because the temperature was high. What causes people to move? And we knew that we couldn't just answer the question with 10 years of data. We needed to take a long-term or a long-jury approach. So just to understand sort of these climate-society interactions, the way society reacts is sort of simplified, but not terribly unclear, I hope. There are climate extremes and hazards, floods. We learned about floods, long-term changes. A lot of you have been talking about long-term changes. And together, these impact biophysical environment, plant growth, human and animal. And once that starts getting impacted, we see economic feedbacks, demographic feedbacks, and at some point it sort of goes into political feedbacks, which is a far more complex process. And because we wanted to understand demographic and economic feedback, I hope that explains why we partner with engineers and also economists. We wanted to look at sort of what are the biophysical effects of climate extremes and are the human environment systems that have come to characterize our living environment over the last millennium consistent with those kinds of risks and changes. So the motivation was really to understand the economic impacts associated with climate variability in semi-arid agroeconomies of the Indian subcontinent. Climate models project that semi-arid regions of peninsular India is going to become more dry, and that at more than 2.5 degrees Celsius, the economic impacts would be far more severe than we can handle with our current socioeconomic structures. Particularly important would be drought, and Asia stands to lose the most. So especially smallholder farmers. So this entire thing was not motivated to understand climate, but to really see whether we can apply our understanding of recent history in order to make some recommendations about sustainability and policies that can keep these regions sustainable over the next century and beyond. So just to give you a sense of what we are expecting, this is the IITM MOES model. Maharashtra, as you can see, is green, and also southern parts of Gujarat. And overall, while red indicates decreasing rainfall trends during the monsoon and blue indicates increasing monsoonal strengths, there are regions that are green indicating that we don't quite understand, or maybe the trends are not statistically significant, and yet on ground, we know that there are issues with hydroclimate and water security, particularly the state of Maharashtra, from where I am zooming in. We see that most of Maharashtra is a semi-arid region, meaning that water balances, evaporation loses water, what we gain from precip, except the coastal regions. And most of these regions is now being converted into sugarcane country, which requires about 1,800 millimeters of rainfall, when several of these interior regions basically get no more than 200 to 300 millimeters of rainfall. So there is a potential problem brewing. We do know that riverbeds tend to run dry during the summer as well as rest of the year. And the puddles of water that collect in these regions are used not just for drinking and washing and hydropower generation and agriculture, but also by subsistence farmers like fishing people that we see here. So, as I said, the motivation was to understand sort of what could be an economic policy that could incentivize preservation of landscape and natural resources, as we are starting to see major conflicts coming into the region, particularly, in this case, we're going to talk about Maharashtra. So the area of study is Maharashtra, and what you see here is sort of the, a zoomed out view of the climate landscape today. And as I mentioned, Maharashtra, most of it is semi-arid and interior. And the blue color indicates wetter, more available moisture. Warmer colors indicate less so. And what we wanted to do was to really create a century-scale record of climate, but also environmental and vegetation changes. And we surveyed the region, and something that we found very commonly were reservoirs, where the rivers come from pretty much here, these basins, northeast to southwest south, and they are dammed. They have been dammed. You can see these dam structures to use the water for hydroelectricity, agriculture, domestic water, all of that. Primarily hydroelectricity and agriculture, but it's also used for water supply and other kinds of activities, as I showed. So our area would be the current focus. So we zoomed into two reservoirs, which we thought would allow us to test this hypothesis, proof of concept. One is the Indira Bazar, which is sort of close to Bombay near Pune, and therefore more wetter. And the other one was Lake Matwali, which is more arid towards the eastern part. So here is the drainage basin for Matwali, and here is what the remote sensing images of the drainage basin of Lake Indira Bazar. And a Google Earth image kind of shows, so this is how the rivers, the feeder streams come and are dammed to the south, and the water sort of builds up over here and are used for varied purposes. Agriculture is quite big. And here is what it looks like on ground. So a lot of these waters are stored in wells, dug wells, we call them, and used for agriculture. And this is how the water, so this is the lake, and those are the duck wells near the lake. So this is how it looks like. And I just showed you, the sort of the environment. And you can see sort of these stratifications, lake stands. We went in the summer, quite a few summers. So those are high lake stands and low lake stands. And you can see that there was forceful water because you see all these cobblestones near these lake layers. So once again, remember, Indira Bazar is sort of near Pune and wetter, and Matwali is to the east, southeast, and in a more drier regime. So this is Matwali, this is Indira Bazar. So very similar latitude and longitude in that way. Only difference is climatological. So one of the first things we did was we wanted to understand the sub-bottom. So the first thing we wanted to do was sort of understand the history of the modern dam structure. And we looked at the satellite images that goes all the way till 1973. And we found that the Matwali, the water kind of structure was there from sort of 1988-89. Before that, there were no sort of structures, no water. So we knew these were more modern. The Indira Bazaar went back all the way till 1973, and there appears to be a drainage pattern that indicates a pre-existing lake, but there were no satellite images prior to that. So the Indira Bazaar seems to be a more older system, just from assessment of...
Please summarize your talk.
So the one thing we did was we first applied geophysics in order to profile the sub-bottom. So the Matwali and the Indira Bazaar. So these parallel line seismic reflections indicate that these are more reservoir-like deposition. And below that, we have more torrential river-like deposition. And we used both gravity coring and vibrocoring in order to look at these two regions. And we got about 1 meter of core using these techniques. Some of these lakes, the Indira Bazaar was drained out of water the day we cored, so we had to do push coring, like walk into the clay pond and get our cores, but we still managed to get them. And what we did was we characterized the core using traditional methods, magnetic susceptibility, core imaging, XRF, and radiometric dating. And what we found was, I don't know what's going on. Sorry, I think... So what we found was that there were two sorts of depositional regimes. I don't know what's going on here. So
please summarize your talk.
Yes, hold on, I am. So what we found here was that the Matwali was more modern. So there is this high rainfall flood-like event of 1988, after which the dam structure was built. So there are three sorts of depositional regime. And then the Indira Bazaar, it was a more continuous deposition, which seemed to be controlled by regional rainfall. And we also basically looked at titanium aluminum ratios to identify peaks associated with rainfall. And we found that there were all these flood events associated with extreme rainfall in the arid region. And there were all these peaks associated with sort of the IDBZ, which is more continuous and reflective of less flooding in the region. In fact, in these areas, during the floods, the amount of sediments deposited were 20 times larger than what we see in the background. So very quickly, reservoirs preserve major hydroclimatic events, requires a multi-pronged approach to characterize and reconcile, bridges critical gap in the domain of climate timescales of human interest, and provides critical management information at local level. And these are ongoing works. I'm going to leave you with that because I've been prodded by Pradeep to quickly complete my talk. So thank you all for your attention.
Thank you, and I'm sorry for stopping you in between. And there are a few appreciations and few questions for you in the chat box that I request you to please address. And yeah, we'll have to move on to the next talk. Is Feroz Khan there?
Yes, sir.
Feroz, please share your presentation.
Okay, sir.
Feroz will be presenting last 20 KA Indian summer monsoon record from Baspa Valley, Northwest Himalaya, India.
Sir,
Feroz, please stick to the time.
Is that visible, sir?
Yes, please go ahead.
Good afternoon, everyone. Today, I will talk about last 20K Indian summer monsoon record from Baspa Valley, Northwest Himalaya. Indian summer monsoon, firstly, term developed by the Halley 1686, which gave the conventional idea about the monsoon and the wind reversal theory. The ISM is an important component of tropical climate system coupled with the global atmospheric circulation, driven mainly by the land-sea thermal contrast and the annual migration of the intertropical convergence zone. The Indian subcontinent possesses two major climatic systems, the monsoon and the western disturbances or the westerlies. In India, in summers from June to September, the India get precipitated approximate 70% due to the southwest monsoon, or it is called southwest monsoon or Indian summer monsoon, mainly by the phenomena is reversed in northeast monsoon or the retreat monsoon. Westerlies developed from the Mediterranean Sea and the Atlantic Ocean. It has two branches, north summer westerlies or southern winter westerlies. In summers, the north summer westerlies blow over the India, but in winters, the southern winter westerlies enter in the India and mainly in the northwestern part of the Himalayan region and get 1/3 of precipitation in Himalayan region in high elevated area in form of snow. The study area is located in the Bhaspa Valley, Kinnaur, Himachal Pradesh. Approximate 1 meter of peat deposit excavated at a high elevation from 3,450 meter above mean sea level. Geologically, the area is located at the transition zone of the higher central Himalaya and the Tethys Himalaya. Mainly the Baspa peat deposit located in the southern fringe of the Tibetan Plateau. The main objective of the study area is to reconstruct the paleoclimate from the area and to understand the mechanism and the temporal changes due to the interplay of the two primary weather systems of the Indian subcontinent. The graph shows the rainfall variability from 1981 to 2017 in the Bhaspa Valley. This shows the age depth model of the peat profile from the area. The black color number shows the radiocarbon edges get from the IUAC Delhi, and the red color number shows the calibrated edges from the study area. This shows the sedimentation rate vary between the 0.3 mm per year to the 0.07 mm per year. To reconstruct the paleoclimate from the study area, we use multi-proxy analysis. For this, we have carbon isotope, environmental magnetism, total organic carbon, AMS 14 dating, and one of biological proxy, that is diatoms. The Delta 13 records are helpful to study the paleo-vegetational history, climatic variability, the regional precipitation of the area. Delta 13 value vary between minus 27.3 to minus 25.3 parts per mil, which indicate the C3 types of plant, which shows the moderate temperature and wet environment. Enhancement in the low magnetic susceptibility shows the cold and dry climate, whereas the decline in the magnetic susceptibility shows the warm and wet climate. The total organic carbon value sediments vary due to the humidity, precipitation, runoff, and salinity, which indicate the productivity of the area. The diatoms are the very sensitive to the climate change. For this, we identify some diatom genus in this study area, which is Pinularia, Diplonis, Rhopaldia, Staurocerella, and Epithemia, which is living in freshwater conditions. Over data from the Delta 13s, we correlate this data from the Indian region, mainly from the Himalayan region and the core monsoon zone lake, which is Lonar Lake. Also, Delta 13 value of over study area, which make the bivariant diagram with the correlation with the latitude and altitude, which indicate the Baspa Valley region is mainly located in the ablation zone of the glacier zone, which have low variability in the carbon isotopes. So this interpretation is well supported by the altitude-based observation, as low altitude peninsular lunar lake shows a broad range of Delta 13 value because it's located in the core monsoon zone and experience extremely wet and dry phase of climate other than high elevated area from the Himalayan region. Our data indicate the mainly 5 phases of ISM changes from 14.9 thousand to 13.9 thousand a year before present. The carbon isotope values depleted, which indicate the Bowling Elrod interglacial period, and after that the one more ISM phase is obtained, which is stronger, that is common warm period. Okay, sir. These are the 5 climatic ISM variability changes obtained. Conclusion of this study area: the record from Baspa Valley indicate that the solar radiation variability in the northern hemisphere is leading cause for the climate change of ISM variability during the mid-late Holocene. From 14.9 to 13.9 Ka, the carbon isotope indicate wet and warm climate, which correlate with the Bolling Elrod interglacial period. From 13.9 to 9.8 thousand before present indicate weakening in the ISM intensity, which correlate with the younger dry cooling phase. The intensity of ISM from 6.8 to 2.4, which correlate from the 4.2 Ka global cooling event, and from ISM was intensified during the 2.4 to 1.3 Ka, which associated with the warm period, and that certain value after 243 years before present slope.
All right. Feroz, thank you for your presentation. And we do not have time for the discussions. And there may be a few questions in the chat box that you may wish to address. Let us move to the next talk. Is Pooja Nitin Saraf is there?
Yes, sir.
Okay, Pooja, please share your screen. Pooja will be presenting using proxy data and vegetation modeling to predict past, current, and future distributional shifts of Bituia monosperma, a therapist for land degradation in India. Interesting. Please move it.
Yes, sir. Good afternoon, everyone. I am Pooja Nitin Saraf, Inspire JRF, working under the supervision of Dr. Jyoti Srivastav. Today, I would like to present our work with you all, that is, using proxy data and vegetational modeling to predict the past, current, and future distributional shift of Bituia monosperma, a therapist for land degradation in India. As we know, the tropical biome is the one which has undergone, which is a world climate domain which has undergone maximum forest deterioration and overexploitation. Climate change is the main driving features in the region for rising temperature and changing precipitation pattern. The Bituia monosperma is an important tree species of dry deciduous forest. It belongs to family Fabaceae and it is a native to tropical and subtropical environment. It has a very great potential to restore and enhance the biological activities in degraded land through nitrogen fixation, and it promotes vegetation establishment. The main objective of our study are to map the most suitable distribution of Bituia monosperma under the past, that is from last glacial maximum and middle Holocene, current and future, as well as to cross-validate the middle Holocene model projection by fossil pollen evidences of the species from various paleovegetational reconstruction studies. Most importantly, to bridge the gap between paleoecology and species distribution modeling by integrating paleontological analysis since last glacial maximum and middle Holocene. Coming to material method, we have selected Bituia monosperma as a targeted species. It is one of the most economically and ecologically important species, and it can regenerate naturally in the mixed deciduous forest. As this species is mainly exploited for various domestic and fuelwood purposes. For the modeling of the species, we have collected the species occurrence data from field survey, and secondary occurrence data have been collected from GBIF, that is Global Biodiversity Information Facility. We have retrieved the environmental variables from World Climate Database version 1.4. All the bioclimatic variables had a special resolution of 30 arc-second. As these bioclimatic variables are highly correlated, hence we perform multicollinearity test using Pearson correlation analysis. For modeling the distribution of Bituia, we used Maxienti software version 3.4.4. The 7 fossil pollen records for middle Holocene were compiled from various published literature. Coming to results and discussion, these are the important bioclimatic variables which we have used to model the species response toward climate variations. Coming to analysis of environmental variable affecting the distribution of Bituia monosperma, the Maxienti result revealed that the Bio4, that is temperature seasonality, and Bio12, that is annual mean precipitation, and along with Bio1 and Bio15 are the main bioclimatic variables which are driving the distribution of the species. Additionally, the Maxent result also revealed that the Bio4 with 39.2% and Bio12 with 15.9% contribute maximum to the distribution of the species. According to the criteria of Sweats, the AUC value, that is area under the curve, is very much useful to measure the performance of the model. Here we have got the AUC value of 0.752, which indicates the moderate performance of our model. The jackknife test is very much helpful to study the impact of each bioclimatic variable on the distribution of the species. The jackknife result shows that the Bio 4 along with Bio 3 and Bio 8 makes a maximum contribution. Current distribution of Butea monosperma in the India. Based on the current climatic condition and bioclimatic variable, the results showed that the Gir region in the western parts and southern western Ghats, including Nilgiri regions and Satmala range in Maharashtra, possess highly and moderately suitable habitat, while in the northeastern region, the low suitable habitat are mainly present in Assam Valley, foothills of Tripura, and Mizo Hill. Heading to distribution of Butea monosperma in future, under the RCP 2.6 and RCP 4.5, the moderately suitable habitat and highly suitable habitat will be going to reduce in the Gir region in the western part and southwestern Ghats. However, we can see the low suitable habitat will going to be entirely diminished in the central India, covering Satpura and Vindhya range. For RCP 6, there is significant decline in highly and moderately suitable habitat in the western and southwestern region. However, in the northeastern region, it will only present in Mizo and Naga hills. In RCP 8.5, we can clearly see there is a sharp decline and where it shows a very small patchy distribution in the western region and southwestern Ghats. Our analysis of percentage change analysis in suitable habitat has shown there is a decrease in highly suitable habitat from the current range and there is increase in unsuitable habitat for RCP 2.6, 4.5, 6 and 8.5 respectively. For LGM and mid-Holocene, there is significant increase in highly suitable habitat while there is decrease in not suitable habitat. The LGM distribution of Butea monosperma in India shows that it covers more suitable area as compared to current climatic scenario. There is a highest probability of Butea monosperma in the Gir region in the western parts and southwestern Ghats covering Satmala range and Nilgiri hills and complete area of Kerala. It also covered the Indo-Gangetic plain and central India region covering Satpura and Vindhya range. Model versus fossil-based distribution of Butea monosperma. In order to assess the performance of species distribution model, we have compared the species distribution projection with fossil pollen data. Here we can see the 5 fossil pollen points of Butea monosperma were located within the low suitable habitat, and 1 record was centered in extremely low suitable habitat. The fossil pollen data supports the distribution of Butea monosperma in the central India region, covering Madhya Pradesh, Uttar Pradesh and Chhattisgarh state, which are estimated as low suitable habitat in the species distribution map. Coming to conclusion, our study will provide very much helpful information about the probable changes in the Butea monosperma distribution in the past, present and future climatic scenario. The habitat suitability of the Butea monosperma tend to decrease from RCP 2.6 to RCP 4.5 with a sharp decline from RCP 6 to 8.5. The broader picture of the 2070 under different RCP suggested that the potential suitable habitat will decrease in southern and western region and the low suitable habitat will sustain in northeastern region. Our study will provide a scientific basis to provide the conservation of Butea monosperma and establish reasonable management practices in the projected suitable area for achieving the optimum production and quality of its resources. Thank you.
Thank you, Pooja, for keeping on time. And we have 1 minute for quick questions. Do we have? Okay. If not, then okay. Anupma madam has a question. Anupma ma'am, please.
Yeah, I just want to know, can you identify Butea monosperma to species level?
Yes, ma'am.
You can?
Yes, ma'am.
Okay, and the other thing is, see, Butea monosperma is one of the avenue trees which is commonly planted all over. So I'm a bit curious to know why you chose this particular species for this work. Actually, first of all, let me commend the work. It's really nice to see this kind of a new approach and modeling approach and also the application of fossil data. I'm just curious to know what made you choose Butea monosperma, because it is kind of a ubiquitous species. So
Yes, ma'am.
in the sense that
Because
it can grow all over and it's also planted everywhere.
Yes.
It's a major avenue tree in
Yes.
most parts of India, in fact.
Yes, ma'am. It is one of the important ecological and important species, and as we can see, it is one of the climate refugia. Means in the extreme condition, it can survive. So
Yes.
if currently we can save this species for future, then that which very much helpful. Means by our prediction, we can see that there is a reduction in highly suitable habitat. So if we started to conserve this species now, then it will going to preserve for future.
Okay.
For
Okay. Thank you.
Thank you, ma'am. Thank you, Pooja. Now I request
you,
the next presenter, Dr. Somnath Kundal.
Yes, sir. I am
Sir,
here, sir.
please share your presentation.
Okay, sir.
Dr. Kundal will be presenting change of biota and fixation of Neogene-Quaternary boundary in Shivalik of Jammu. Okay. Please share your screen, sir.
Okay, sir. Sir, screen is seen you? Hello?
Yes, please make it full screen.
Okay, sir. So today my topic is the change of biota and fixation of Neogene-Quaternary boundary in the Shivalik of Jammu. An overview. So A is the range of Shivalik hills.
Can you make it full screen, sir? Is it possible?
Oh, okay, sir.
Yes, this is the one.
So Shivalik is the southernmost most part of the Himalaya, and it ranges from Bhutan to this one in Pakistan. And here is my study area in the Jammu region. So this is the locality and geological map of the Shivalik of Jammu. So there is lower Shivalik, then middle Shivalik, then Permandal sandstone, then Nagrota formation and boulder conglomerate. So Permandal sandstone, Nagrota formation and boulder conglomerates is come under the upper Shivalik subgroup of Jammu. So my work focuses on this Pinjore formation, that is the Nagrota formation of this Jammu area. Then next, this is the comparative lithostratigraphic classification of Shivalik of Jammu. So
no, your screen is not moving. Your slides are not moving. We are still on the second slide.
There is
We're still on the second slide.
Sir, it is third now.
Now it is, but it's not full screen, sir.
Sir, here is full screen.
Anyways, please go ahead.
So the local classification of Jammu given by Gupta and Burma in 1988, that is the Monsoon formation, Deval formation, and then Mohargarh formation, and in the upper Shivalik subgroup there is a Uttarvani formation, which includes the Lovely member and Marikhui member, and then the Dagor formation. And Rangarao classified this upper Shivalik subgroup of Jammu into Permandal sandstone, Nagrota formation, and Tabi conglomerate. Then Agarwal 1993 gave the classification, adopted the classification of Rangarao, and classified the Nagrota formation into Nagrota member A, Nagrota member B, Nagrota member C, and then Elias et al. 2017 classified the upper Shivalik of Jammu into Mansar, Deval, Mohargarh formation, then Lovely formation, then Marikhui formation, and Dagor formation. So my work is focused on the Nagrota formation. Then this is the profile of the upper Shivalik subgroup of Jammu region. So here is a Pinjore, boulder conglomerate, Then there is a tetrode and doptan. So this is the magnetic polarity stratigraphy and final succession of the Permandal Uttarveni sections given by Rangarao 1988. And here is the vertebrate fauna existing in the different locations in the litho column. Here is two bands of the volcanic ash beds. One is lower one and other one is over one. And this is the magnetostratigraphy. And the volcanic ash bed is coincide with the Gauss Motajama boundary, that is 2.48 million year. So bentonite band acts as a reliable time marker horizon in the upper Siwalik subgroup of Jammu. Exposed at 22 localities having same strike. So maximum thickness of the bentonite tooth band is 3.6 meter at Vadakhetar and minimum thickness is 2 centimeter at Khirdi section. So radiometric dates of the bentonite tooth band from time to time Y. Tripathi 1996 gave the age of 1.6 plus minus 0.2 million years for Jirkan fusion track dates of Uttarveni sections. Then Jakojama gave 1987 gave an age of 1.6 plus minus 0.56 million year for Jirkan FE dates for Badakhetar section. Then Rangarao et al. 98 gave 2.8 plus minus 0.56 million year and 2.31 plus minus 0.5 million 4 million year FT dates of bentonite tooth band, Badakhetar and Nagrota formations. So in conjunction with magnetostratigraphy, Rangarao et al. 1998 arrived at the conclusion that these bentonite tooth bands straddle across the Gauss Motajama boundary, that is 2.48 million years. Then after this, Mehta et al. 1993 gave age 1.59 plus minus 0.32 million year of this Badakhetar section. So this is the Badakhetar section. So below this one bentonite tooth band is the mudstone horizon, and above the bentonite tooth band is the siltstone.
Sir, you have 2 minutes to summarize.
So
I would suggest please come down to the conclusion.
Okay, sir.
That will be better, yeah.
So according to the Agarwal 1993, the faunal changes about 60 meters below the Gauss Motajama boundary. There are different few views regarding the changes of fauna and flora interval zones. No author till date identified the particular section of the Paleocene boundary and the faunal flora interval zones in the Siwalik of Jammu. So during the last 10 years, I have recovered a lot of fossil specimens from the mudstone horizon underlying the volcanic ash beds. The fossil includes 22 species of these trace fossils within the ash beds, and 18 species of the astrogods, then gastropod 5 species, bivalves 2, charophytes 7, then one is the angiosperm seeds, Boragino lachanpalis, and including this one, the lizards and rodents and elephants, such as Ellipse planifrons, Tigodon, and Ellipse planiform, recovered from within the ash bed or underlying the ash beds. So these are the various biointerval zones of various authors given proposed by the interval ellipse planiform zones. So conclusion, no exact dates of the ash beds, but Rangarao et al. 1998 dates are reliable a few extent as it is based on the vertebrate paleontology, magnetostratigraphy, and fission track dating. No particular Paleocene boundary section identified till date, which we say that this particular section is the Paleocene boundary section. For this, I would like to propose Badakhetar section as a reference section for Paleocene boundary. The reason for that, ash bed or bentonite tooth band is equated coincide with the Gauss Motajama magnetic polarity scale. Ash bed is the marker horizon in the Siwalik, fauna and flora recovered from within the ash bed and associated fossiliferous mudstone indicates a late Pliocene, early Pleistocene age. There is a change in taxa underlying and overlaying the ash beds. This faunal and flora changes also observed in the microvertebrates, micro and macro fossils, and megavertebrates taxa. The mudstone horizon underlying
I believe I have to stop your presentation, sir, because it's time to summarize, I guess. Finish your talk. Yeah, thank you.
So, no particular. Okay, sir. Thank you.
Sir. Thank you.
Okay, sir.
If anyone of the audience have specific questions, please chat. Please put your questions in the chat box, and we'll have the answers from Dr. Kundal. Thank you, Dr. Kundal. I'm sorry for stopping you. The next presenter of the morning is Dr. Jyoti. Jyoti, you are here.
Yes, sir, I'm here.
Jyoti, please share your presentation.
Sure, sir.
And Jyoti will be presenting ensemble modeling approach to predict past and future climate suitability for 2 mangrove species along the coastal wetlands of India. Great. Please go ahead.
Thank you, sir. Very good afternoon to everyone here. Well, I would be presenting an ensemble modeling approach to predict the past, future climate suitabilities of the 2 important mangrove species along the coastal wetlands of India. And as we know, the tropical and the subtropical intertidal plant communities are dominated by mangroves, and these mangroves are essential ecosystem providers and have a direct impact on the coastal human livelihood. And these mangrove species are facing drastic deterioration due to climate change as well as human activities. Recent studies have shown that there has been a decline in the rate of loss of these mangrove species. But this study is mainly regional, and this decline in the loss is regional, and especially in the developing countries, still these mangrove ecosystems are facing a drastic loss, which is harmful for our livelihood, our coastal livelihood. And here we are presenting this ensemble modeling technique based on the mangrove zonation along the eastern coastline, along the Indian coastline. And here we have targeted 2 mangrove species, first being Rhizophora mucronata, that is on the intertidal coasts, and they are mainly fringing along the channel margin along the coastline, and these mangroves require tidal inundation throughout the year. And the second species which we have targeted is Abyssinia officinalis, which is towards the landward zone of the Indian coastline. They are zoned on the basis of salinity, inundation, and sedimentation rate. This Abyssinia officinalis is generally present along the landward side towards the inland region. They are generally not found along the channel margin, and they require tidal inundation only during high tides, only in the supratidal condition. So we have selected these 2 targeted species based on their widest distribution in the region and their varied preferences in estuary locations. Now coming to the methodology of this modeling approach, first stage is the data set processing and preparation, which requires data set accumulation from species occurrence data from the present time, bioclimatic data from various databases, elevation data, and fossil pollen data. We compiled all these data sets, and the autocorrelated variables were removed, and the selected bioclimatic variables were modeled along with the species occurrence data using ensemble modeling approach. Here I would like to emphasize, this is based on species distribution modeling.
Yes,
ma'am.
Your slides are not moving. Sorry to interrupt, your slides are not moving, and we are not seeing a full slide mode.
Okay, actually, is it full slide mode? I'll go back again.
They're not moving.
I'll share it again then.
Yes.
Is the screen up now? Is the screen up now?
Yes, make it full screen.
I've made it full screen.
Then I guess you have to switch your slides from the left panel, because it's not, still we are not able to see full screen.
Then I have changed it to a normal screen. Is it fine? Now is it changing?
Yes, please.
Is it changing? Okay, I'll go this way only. So next, I was in the methodology part. Is it moving now?
Yes, please go ahead.
Yes. So in the third stage, we do the model evaluation, in which we evaluate the predictive model of the current environment, current climatic scenarios through kappa and receiver operating characteristic and true still statistics, whereas the past distribution model was validated on the basis of fossil pollen data, that is the middle Holocene species occurrence data points, to improve the predictive ability, robustness, reliability, and significance of the Paleo-SDM analysis. Coming to the dataset resources and model description, we generated this primary occurrence data points by field surveys in the mangrove wetlands along the southeast coast of India, and the secondary datasets from published literature, Global Biodiversity Information Facility, and in Indian Biodiversity Portal, whereas the environmental variables, including 19 bioclimatic variables and the altitude, makes it 20 environmental variables, were extracted from the World Climate Database for the current, future, that is for 2050 and 2070 time scenarios, and also for the past, that is the middle Holocene, around 6,000 years ago time span, using the adopted model of the IPCC in the fifth assessment. And thirdly, the ensemble model design was made on the basis of Biomod 2 package in our software, and this is a combination of 5 algorithms, including the maximum entropy, that is MaxENT, Mars, generalized linear model, FDA, and random forest model, that is a modern machine learning approach. So we did not take single algorithm model, as generally the single algorithm models, they give a similar performance, but their habitat suitability estimates is different. So in order to cross that bias, we integrated all the algorithms to make it more robust and made it an ensemble model design for it. So the results show that the model performance was preferably excellent on the basis of AUC values and the TSS values, and even the sensitivity of the model was high, which is showing that the model was showing the correct distribution of the species present, whereas the specificity was also high, showing the correct distribution of the absence of these species. Okay, coming to the predictor values. The predictor variable importance, how the variables were selected, they were on the basis of the correlation, and highly correlated values were extracted, and on the basis of that, it was seen that Rhizophora mucronata was distribution was changing highly significantly on the basis of precipitation of the warmest quarter and that is the precipitation seasonality. Whereas for Abyssinia officinalis, the precipitation seasonality was the most significant factor which was affecting its distribution. Okay, coming to the current projection of the mangrove species along the Indian coastline. Are you able to see the full screen now? Is the slide moving?
Slide is moving, but it's not the full screen.
Okay, so this is the current projection of the mangrove species along the Indian coastline, and these blue dots show the Abyssinia officinalis current distribution, and this is the occurrence data points. Here we see the extremely suitable habitats are mainly found in the Pichavaram area, the Vembanad area, and also in the Coringa mangrove area. In the Mahanadi Delta, we see moderately suitable habitats. Now coming to the past projection of the mangrove species, especially the Rhizophora mucronata. This is the past projection, that is the middle Holocene time span projection. And here we see a rise in the
only the current projection.
Oh, it's again not changing. I'll change it to that one. Is it fine now? Past projection?
Right. Yes, it's past projection now.
Okay, so this is for Abyssinia officinalis, and here we see an increase in the highly suitable habitat in the Pichavaram area, in the Kerala coast, and also along the Maharashtra coast. Whereas there is a decline in the there is not much highly suitable habitat in the Sundarbans area. Coming to the future projection, in 2050, we see a drastic decline in the extremely suitable as well as highly suitable habitat. This is for RCP 8.5, where it is said that during the 21st century, there would be a throughout increase in the GHG greenhouse gas emissions, and the temperature would rise in 21st century around 5 degrees Celsius, which is the worst case of climate change scenario in future. And here we see only moderately suitable habitat found in the Koringa area and also in Sundarbans in some parts in patches, whereas low suitable habitat will also decline from the southern part of India. And then coming to 2070, here in Office Analysis, we see again a decline in the extremely suitable habitat, with low suitable habitats in other parts of India and moderately suitable habitats in Sundarbans, Chilika, that is the Mahanadi Delta, and in the Dwarika coast. So this is how we have projected the mangrove habitat in current and future climate scenarios, which shows a decrease, which indicates high vulnerability of the species to climate change impacts. And these mangrove species are projected to shift in their ranges in future, with a decrease in the suitable coastal areas which was available to them in the Indian coastline. And with that, we see that Pichavaram, Muthupet, Koringa, Krishna mangroves, and the Konkan Kerala coast mangroves have forecasted to see severe decline with a complete loss of stable habitats. Whereas Sundarbans, Bhitakarnika, Mahanadi mangroves, along with Chilika, would be conserving both the mangrove species in the low and moderately suitable habitat along the east coast of India. Whereas Dwarika coast, also in the Gujarat, along the west coast, will also be targeted as an area of mangrove biodiversity conservation during the anticipated future climate change scenario. Our findings will assist in formulating species-specific restoration plans for mangroves in context to climate change in the Indian subcontinent. Thank you.
Thank you, Jyoti. And we have 1 minute for quick questions if there are any. Krishna ma'am, Anupma ma'am.
Yeah, Jyoti.
Yes, ma'am.
That's a nice presentation. Thank you.
Thank you.
I'm just curious why you used a lot of factors except the sea level and also the salinity, which are the most important for species.
True, ma'am. I agree with that. And ma'am, this is the next step of this analysis. This is the initial stage. So we have only taken the environmental variables, and now we have to collect the database for sea level changes and salinity. And surely we will be adding that in the future study. This is the first stage of that study. And yes, we required the salinity and the sea level change data also. So, ma'am, the data collection is time taking, and that is also like we are lacking in that.
Okay.
Yes,
Thank you.
ma'am. Thank you, ma'am.
Yeah, Rajesh?
I have a just added question here, Jyoti, because part of my question Anupma has already asked. My question is, let us say with your projections, whether they are right or wrong, that is a different thing. But what kind of carbon capture is taking place because of these mangrove areas where you are working on? And if you have, because you are now talking about the modeling studies, if you kind of preserve these mangroves where you have shown the hotspots, how much carbon you can sequester by 2070? Any angle?
So if we are able to conserve these mangrove habitats, definitely carbon sequestration will be enhanced in these areas. But main problem is the conservation part. Like as we know, we are from developing countries, the response capacity is very low. Like we still have to make that awareness done. So yes, it will be enhanced. I can't tell the figures, but it will definitely be enhanced as mangroves are the main components for carbon sequestration, especially in the coastal areas. So definitely, if we are conserving that, then it will be done. Otherwise, there will be a loss.
I think in coastal areas, what Anupma ji is saying, I am seconding to it, but it is my prime concern rather than the climate. I think the seawater intrusions are mainly the real causes.
Exactly, sir. Actually, this is only the first half of the study, and we wanted to include salinity and sea level change. But this data compilation is very time consuming, and we are going to add in the final studies the salinity and the sea level change. Actually, getting the data from various databases, like Soil Grids is the database from where we have to extract the salinity data, sediment salinity, pH data, and definitely we'll be adding that to the study, because for coastal areas, this is of prime importance.
Okay, thank you. With this, I close the session. I mean, the session has been a wonderful time we spent, and all the speakers largely kept the time. And I'm sorry for a couple of speakers that I have to stop in between. If anyone of the seniors want to comment anything, I would request remarks from them, or else I'll ask Rajesh to please summarize if you want to add anything to the session. Rajesh?
Okay. Thank you, Pradeep. I think this session was wonderful, and it had many aspects, as we have seen right from, the keynote address from Professor Bob Wasson, and then Azhar, we went to the South Pole, and we talked about the tropical area vulnerabilities, and also, sometime I just feel it is my submission that time was little less. Otherwise, this Dr. Kundal's talk was also very nice. Actually, I was trying to get into it, but not enough time was there. But overall, I think everybody would agree that all the people could present very well within time. 10-minute time is short, I know. And I think I, from my own behalf and the SIP behalf, congratulate organizers of IQC for having this wonderful session. Thank you very much.
Thank you, Rajesh, and we'll definitely find some time sometime to invite the speakers who could not speak. Who could not present their full talk.
Yeah.
That is what I was thinking. So thank you. Over to you, Benita, now.
Thank you, Pradeep. Thank you, Rajesh, for conducting the session so well. So we break down for lunch. It's a break, coffee break or the lunch break. But we meet in half an hour, that is 1:30, with the poster session. So we have 18 very interesting posters. And I request the poster presenters to be there. And we would be screening the posters from here. And they'll get 5 minutes to talk on that. So just prepare it as a concise talk, because there we are having all the more less time. So because we had such a overwhelming response for this IQC 2022, there were so many, more than 90 abstracts that we received. You must have seen the abstract volume. So it's very hard to accommodate everything. And we wanted to listen to all of you. So I hope you understand what our situation as organizers was here. So thank you once again. I hope you had a wonderful morning session, and we'll meet again for a yet interesting poster session in the afternoon, just after lunch. Thank you. So the link will be open, and we'll stop recording from here. And at 1:20 maybe the link will be open. So please join again, and you can keep joining also. Thank you. Bye. Bye.